Hi, future doctors. Welcome to the next class. So, in this class, we will discuss about net force. Net force when object moves. In previous class, we discussed equilibrium condition. Now we will see when our object is moving, how resultant force we are going to write. If you are taking any object on the surface, how many forces are acting on that mass means two forces. One is gravitational force, another one is reactant force. Let us assume we are making this object to move in upward direction with acceleration a. Then what is the resultant force? Now this is the object. Let us assume we are bringing this object like this upwards. At the time, the force applied by my hand is more than gravitational force which is acting downwards. Correct? So therefore, resultant force, how we are going to write means resultant force equal to N is greater than mg if it is moving upwards. Therefore, resultant force, how we will write means N minus mg. This mass is constant. Therefore, according to Newton's second law, if mass is constant, we will write resultant force ma. So N minus mg. Then N is equal to mg plus mg. So this is the reactant force when object moves upwards. Next up, same object is moving downwards with acceleration. If it is moving downwards, which force is more known? Mg is greater than N. Therefore, now resultant force is mg minus N because mg is greater than N. According to Newton's second law, if mass is constant, like this. Now N equal to mg minus ma. So mg term will be added by ma if object is moving upwards with acceleration a. Mg term subtracted with the ma if it is moving downwards. Therefore, whenever you are going upwards on a staircase, so whenever you are going upwards, you will feel uncomfortable after reaching top floor. Why? Because your weight term is going to increase this much. So, but whenever you are coming downwards, you will be feeling free because your weight is going to be decreasing. So, if you jump from here, let us assume, then your acceleration is acceleration due to gravity. So then N is equal to mg minus, in place of this acceleration, we have to take mg. So your weight will become 0. Therefore, you will feel weightlessness. If you keep one weighing machine for your legs and if you jump from top floor means, you will feel weightlessness. But don't jump, just I am saying, it is going to become 0. You will feel weightlessness. Next up, if you are moving with constant velocity, so if you move constant velocity with constant velocity in upwards, if velocity is constant, what is its acceleration? 0. Therefore, if you move upwards, if you move downwards, your weight is going to act same, isn't it? So this is going to be normal reaction is going to be equal to weight if you are moving with constant velocity. Next, if you are suspending an object by a string, mass m, weight is acting downwards. In this string, what will be developed? Tensional force will be developed. If object is at rest, T equal to mg. Now this object is moving upwards with acceleration a. Then what is the tensional force developed in this string means? The resultant force. So which is more? If it is moving upwards means T is greater than mg. Therefore, T minus mg. So ma equal to T minus mg. Then T is equal to mg plus mg. See, previous one and this one both are same. But here N is there. Here tensional force is there because it is suspended by string. Next, if it is moving downwards, we are making it, this object is downwards. So we are making a rope or small thread. We are holding this and we are making it downwards to move. So mg, T. Now which is more? Mg is greater than T. Therefore, resultant force mg minus T. MA equal to mg minus T. So T is equal to mg minus MA. So blindly you can remember that if object is moving upwards, either tensional force. If object is suspended by string, you will get tensional force. You will get mg plus MA. If it is on floor, you will get mg plus MA. Both are upwards. Next, if it is moving downwards, mg minus MA. If it is moving downwards, mg minus MA. A person is taking water tins in a lift. If lift is moving upwards with acceleration A, so then you have to use this formula to find the weight. Isn't it? So blindly you can remember if object is moving upwards, plus will be coming. If object is moving downwards, minus will be coming. So how they will ask problem on this? So they won't say an object mass is pulling upwards. A rope is going to be suspended. A small monkey is going to be moving, not one, sometimes so many they will give. Presently we are seeing one monkey of mass m is moving upwards with acceleration g by 4 something they will give. Then what is the tensional force developed in this string? So upwards means you have to take mg plus ma. So mg plus m with g by 4 it is going. So mg if it is common 1 plus 1 by 4. So mg into 5 by 4. So 5 mg by 4 is the tensional force developed in this string. And in this, if someone cut the rope, how this monkey, with what acceleration this monkey is moving downwards. If someone cut the rope, this object is moving with resultant force mg. So therefore, net force ma equal to mg. So a is going to be g. So in this case, it is moving with acceleration g. Next, they will give a person is moving in a lift, means how to apply the equations for the given problem. A person is moving in a lift, he is standing on weighing machine. So when he is moving upwards, his weight is going to be 60 newtons they will give. When it is moving downwards, weight is going to be 40 newtons they will give. Now when lift is at rest position or lift is moving with constant velocity. Now what is the weight of this person they will ask. At the time how to do means when lift is moving upwards, W1 is equal to what is our formula? Mg plus Ma. So when lift is moving downwards, W2 equal to Mg minus Ma. When lift is at rest, W equal to Mg. Whether constant or rest, both are going to be same. So if you want Mg from these two equations, what you have to do means Ma should be eliminated. Therefore, add these two. If you add these two, W1 plus W2 equal to Ma will be cancelled to Mg. In place of Mg, what we can write? Double. So therefore, weight when lift is at rest or moves with constant velocity. This is the formula. Sometimes they will ask formula, sometimes they will ask problem. 60 plus 40 by 2. So his original weight is 50 newtons. We will say 50 kg. 50 kg is not weight, that is mass. So 50 kg weight you have to say, otherwise 15 newton. This is going to be how we are going to solve. So whenever object is not under equilibrium condition, if it is moving upwards or downwards, we have to follow equations like this. So upwards means mg plus mg. Downwards means mg minus mg. Isn't it? So like this we have to solve. So try to solve some problems on this. You will get easily. Thank you.